Welcome to our mini Amazon website. Let's first register a new account by clicking on the sign up link below. Here we'll fill in all the fields. Great, we have been successfully registered.
Now we can go to the login page, and we're going to log in on an account that we've made before because it has entries filled in for our cart and our purchase history, so it'll just make it easier to visualize. So we'll go ahead and log in, and so here you can see we're directed to the home page, which gives us recommendations about the top items in the marketplace. And then here on the left, we have we've logged in a different browser as a seller as opposed to a buyer. And so we can see that there's a special page for the seller to be able to manage their items.
Okay, so this is the seller page. You can see we have all the listed items for the seller below, and then we can also create a new item. And when we submit, we can see our new listing below. And we can also modify existing listings, and it'll pre-populate the listing.
So now, if we were the buyer, we can go ahead and search for the new item that we've added. And I think Nico's going to talk about that.
Yeah, so let's search the item that was just listed by our seller on the other page. Let's search raccoon. Now, if we click on that item, it'll take us to the item page where we can view the item's average rating, the price, the quantity, the reviews, and also the ability to add the item to our cart. So let's add 2.
So once we've added to our cart, we can now go to our cart page if we want to check out, and we can see that our item is here. We're able to subtract or add more items if we want. So let's say we actually decided that we want to buy 7 items. If we try to purchase it, you can see we'll get an error because we previously only added 5 items, so that's not going to work. So we'll try and subtract more. We realize we don't have enough money for that, so we'll subtract even further. So with 1, we probably should have enough money. So if we purchase it, we can see that our purchase was successful. And if we go to our purchase history, we can now see that our purchase of this raccoon is now successfully in our purchase history. And so once we purchase our raccoon, if we want to make a review, we can also do that, which Justin's going to talk about now.
Okay, so let's say we want to add a review. So right now we're a buyer and we're logged in, so our email is kept in session storage. Let's see what that looks like in the form. So as I said, the email is not here because the session handles it. But as for other information, the review also requires a valid storefront email that's stored in the storefront table of the database. If it's not a valid seller, the review won't get added. Similarly with the item ID of the thing that we just bought. From here, the buyer is free to rate the item and the quality of the transaction with the seller, and the review text can be anything. Let's submit the review. Once the review's been added and the page has been refreshed, the page will fetch and display the new set of reviews for the session user. Right now, the front end renders in the order the tuples are in the database, and we can see the new one on the bottom. As for editing, the page fetches data for the particular review. We don't allow the user to modify the item ID or storefront email because this is only an update function. However, the user is free to change rating values and review text.
Seller side, since this was purchased from us, if we go to our order history, we can see that this has now been added to our order history with the date, how many items, and the price at which it was purchased at. So now we have an accurate history of all the things that we've sold on our website. So I want to talk a little bit more about some of the finer details of how our backend works and how it interfaces with our front end. So here we can see our models.py, which contains all of the relations in our SQLite database. And so here we can see we have a buyer relation, which includes information like email, password, name, and balance. And we have a storefront relation, which represents basically someone who wants to sell items that contains similar information. Then we have this item relation, which contains an ID as well as name, description, and category. Finally, we have a listing, which essentially represents a specific instance of a store trying to sell a specific item. So you can see that we have item ID and storefront email, which are both foreign keys, which essentially uniquely identify a specific item in a storefront. Cart is essentially a relation between a buyer and an item and specific selling. So we also have these foreign keys that include an item ID to identify the item and the buyer email, which indicates which buyer has this in their cart. Purchases are very similar to cart, except we include this date time construct, which represents when the item was purchased at. And finally, we have reviews, which once again includes these foreign keys that relate a buyer to a specific listing, which includes an item ID and a storefront email. And then of course, the information that actually represents the review, which is the rating and the specific review text that the user inputted. And so to populate this data with a production size data set, we found this Kaggle data set online, which contains over 30,000 tuples representing different Amazon products and the information that they could find on it, including the name, image URL, the category, as well as up to 4 different sellers and what price point they were selling this item at. And so to populate our database, we wrote this Python script that utilizes the pandas Python package. And so what we do is we load this CSV in, and then we iterate through every row in the CSV, clean the data a little bit to make sure that there aren't any sort of empty or null strings if there are, for example, missing descriptions. And then we insert all the items and we insert all of the valid stores that we find. And then finally, for each of those stores with that price, we insert a listing value that includes the price that they were selling that item at. In order to populate our buyer, cart, purchase, and reviews relations, we needed to utilize a slightly different approach because due to privacy reasons, it was pretty hard to find a data set that included people's first names and last names. So what we did was we artificially created this. We defined this schema that essentially creates a random set of people and random purchases and carts. And so we found this website online that helped us generate this schema. And so this is the result right here. This JSON file that essentially it's over 200,000 lines long, and it essentially has randomly generated reviews, people's names and emails, etc. And so then in our procurement script, we load in that JSON file, and then we essentially iterate through and insert all those randomly generated reviews, purchases, etc. So now I want to talk about a specific example of how this database interfaces with our front end. So we can see here in our cart, if we click on this purchase button, we're going to be calling this purchase cart endpoint in our Flask backend. And so one really cool feature about this is that we utilized a transaction, which allows us to roll back the transaction if at some point during our purchase, we realize that this purchase shouldn't go through for whatever reason at all. So for example, if I click on this update button, or if I click on this purchase button here, I'll get an alert saying that there was not enough item in stock. So when I press OK and I try to refresh, you'll realize that the purchase didn't go through at all. And none of the items went through because that one item was not in stock. And if you go to our purchase history, none of those items were purchased at all. And the reason why this transaction is really powerful is because, as you notice, as part of the purchase, we have to iterate through every item in our cart and make this insert statement, the purchase schema, so that we can, the purchase relation, so that we can add a purchase entry for that specific selling for this user. But we also need to fetch the quantity of that specific listing and make sure that there's enough items that we can actually purchase that quantity that we want to. And so if the event that there isn't enough, which is the event that just happened, we can call this transaction rollback function, which will roll back the transaction. And that means that even though we did call these insert statements previously, when we roll back the transaction, that ensures that none of those insert statements actually persist, which means that this purchase function truly is atomic, and that either all the items can get purchased, or if there's a failure, then we roll back and we make sure that none of them are purchased. And a similar thing can happen, for example, just as a quick overview, if I go to the balance page, you can see that I have $1,300 right now. And so if I reduce this, let's say I reduce this quantity down so that there actually is enough for us to purchase this item, but the price is still above 1,300. If I try to click purchase, you'll see that there were insufficient funds to complete our transaction. And once again, that's essentially this stage right here, which is after we've technically called this insert statement on every single item to insert into our purchase relation. We can still roll back that transaction, and you can see that all the items are still in our cart. They weren't removed. None of it is in our purchase history. And if we go to our balance, all the balance is still there. And so if we add, finally, if we can add enough money and now go to our cart, if we purchase, we'll see that finally it succeeded atomically. Everything went through. If we go to our purchase history, everything was bought. And if we go to our balance, we can see that our balance was indeed subtracted. And so that shows how by using transactions, we're able to interface our interface with our database in a way that makes sure that we have consistent results and that we aren't subtracting money from a buyer, but not actually giving them the item or giving the money to the seller or any other sort of inconsistent state. So, and this also demonstrates how sort of our React front end calls these endpoints in our backend, which then can make these insert, update, or delete statements onto our database.
One challenge that we faced was authenticating users at login and passing users' data through the various components, which we accomplished through session storage. To avoid unauthenticated users from accessing certain pages, we implemented class-protected routes that redirect a user that is not signed in to the login portal. Another challenge that we had was working with pictures for items and listings. We were able to procure data that had photo URLs for all of our cleaned entries, but we had to figure out how to store the photos for new listings and settled on using Imgur's API to upload photos, get back the photo URL, and store it in our database. Our database also presented us with a bit of a challenge. Upon making changes to the database, we kept running into issues with version control by getting merge conflicts in the database file. This could have been mitigated by using a cloud-hosted database. We also faced some challenges with hosting our application. Because Netlify requires HTTPS, it was a struggle for us to figure out how to ensure Flask had a valid SSL certificate and compiled with HTTPS. Given more time, we may have implemented additional features such as storefronts being able to show when an item is on sale, filtering our search results by price and category, and personalizing the recommended items on the main page so that it recommends items to the users based on the specific user's purchase history. To see how well our website scales, we would also be interested in procuring more data to be able to judge how performance is affected with upwards of 1 million tuples. Some components of the website are already suffering from scalability issues, so addressing those would be an immediate next step. Additionally, authentication should ideally be accomplished by sending a hash derived from the password as opposed to the password itself, or some alternative form of password encryption and decryption to address security concerns.
All right, so I'm going to talk about how we handle SQL injections. So one way we help prevent SQL injections is using an ORM. We used Flask SQL Alchemy, and as you can see here, this query is being executed in the Flask SQL Alchemy model. And while nothing is necessarily 100% effective at preventing SQL injection, we thought that using an ORM was a good step towards providing our database some more robustness and some more security. Another way we prevented SQL injection was through parameterized queries. As you can see here, this query is parameterized, and that means that all the values are being replaced by question marks, and then the values are being passed in as a second argument to this database.engine.execute. And you can see here some documentation from SQLite 3 Python explaining why SQL injections are prevented by parameterized queries and how to create a parameterized query. And while we used Flask SQL Alchemy instead of SQLite 3 Python connector, the idea still remains the same and it's still relevant and applicable. And parameterized queries helps us prevent against SQL injection.